Well, good evening. I'm Charles Schultz with Schultz Laboratories and Universe Science Center, and this is the randomizer for the 16th of February, Wednesday, 2022. Tonight's technical term is a little different. It is miscible. Now, many of you may not have heard of this word, but it is an important term that describes something we run into all the time. And we're going to get right down into it, and I think you might learn a couple of very useful tricks in your life for things that involve this exact term. What is miscible? It literally means able to be mixed or dissolved in. And if you look, the perfect example, the one that everybody knows about, it's oil and water. We know that the two will not mix. And we're going to get into what we can do, how we change that, and how life can be a little better with a minor bit of chemical enhancement here. First of all, I want to thank all of our supporters and subscribers. And I would like to convince a lot of people to join us because things are getting better every day here at schultzlaboratories.com and universesciencecenter.com. We are expanding our galleries and adding more virtual rooms. The astronomy rooms are being expanded right now, and I'm adding an entire sky globe showing exactly what the astronomical terms such as plane of the ecliptic, right ascension, declination, those terms are in there and will be in such a format that you can walk right in, play with them a little, and get familiar with them. So you're going to learn a little bit about astronomy when you visit our new additions to our space rooms. Get your Oculus or any sort of 3D headset, walk around in there, enjoy the virtual environment, and I think you'll come away feeling a lot better about science and knowledge in general. Go ahead and sign up for our 9 p.m. Monday classes. Meta World Class 4 will be on the 21st of February, and we're going to be talking about, well, how we're moving along technically from sticks and fire to nanotechnology. And refining control was our last lesson. We're going to be on explosive growth and limits on the new one. That's 9 p.m. Mondays, Eastern Standard Time. And of course, randomizers every weekday, 6 p.m. Eastern Standard Time. So let's get into soap and water and the term miscible. If you were to take a glass of water and pour some oil into it, cooking oil, let's say, as an example, and you would find the two would separate very readily. The water, being dense, would be at the bottom of the container, and the oil, being about 60 to 70% that density, would rise to the top. The issue here is that the molecules do not join very easily. They're not exactly compatible with each other. Water is what's known as a polar covalent molecule. And basically, it's just a fancy term for telling you how the hydrogen and oxygen are bonded together and how they will react with other materials. Let's say you put some salt in there, and salt is an ionic compound. And what it does when you put it in water is the water molecules take the atoms out of the salt individually and make charged ions in solution. And this can't happen with oil because of the way the oil is bound together. Its molecule doesn't undergo that sort of a transformation. So, unable to be ionized, the oil will not dissolve in the water. Now, you can take high-speed mixers or even an ultrasonic transducer, and you can blend it up by breaking the droplets very, very, very finely, down to a stage known as the colloid phase. And it can remain suspended like that for a long time. Mayonnaise is a colloid. It's a mixture of a liquid and a gas, or two liquids suspended together that don't separate out. Oil and water can be done that way. Milk also has a colloid component to it. There's butterfat in it. But it's in such tiny droplets that it doesn't separate easily. And they're bound in such a way that they're fairly stable. But water and oil, there are things you can use that will make the two mix properly, will make them miscible. So this works when you use certain materials such as soaps or detergents or emulsifiers. And many people will sometimes ask, and this is a sidetrack, but it's very important, the difference between a soap and a detergent. So soaps are generally made of natural components, such as a vegetable oil or acids from an animal fat. And you usually mix them with some sort of an alkali. In the past, they'd use lye, sodium hydroxide derived from wood ash or potash. And you'd make lye soap that way. So you'd have a big vat and you'd put your fats in there that had been rendered and filtered, and you'd add the lye and you'd cook them for a while, and the lye would chemically react with it through a process known as saponification, which literally means making soap, but it's a chemistry term. A detergent, on the other hand, is made from man-made or artificial materials. So detergents are different because they are not made from natural source materials, basically. They do the same thing, however. And so let's look at what happens. Let's say you are cleaning the dishes and you have a greasy pan. Well, what do? You dip it right in the sink with the soapy water. That can work if there's not much grease. But if there's more grease, you need to put a little bit of dish detergent directly on it and work it into the surface and then wet it. The moment you get the water on the oil, it basically forms a barrier that makes it difficult to separate the material off of your pan. You can't clean it off. I'll give you a better example, something that's very practical, and this is going to help you in your everyday life. You've worked on your automobile, you've worked on something greasy, a big machine or something, fixing the lawnmower, whatever, and your hands are covered with black grease, and man, you got like 10 minutes to get ready for something, and you got to get your hands clean. What do? The very worst thing is to wet them. Don't do that. There are two tricks you can use. Number one, if you have clean, let's say cooking oil or Crisco or some sort of vegetable shortening, put that on your hands, rub it in all over until you've coated every square centimeter, and wipe it off on an old rag or a paper towel, and that will take a great deal of the black grease off right away, because oil will dissolve in oil. That's pretty simple. But then you take another step. Get your dish detergent, and these seems to work a little better. Laundry detergent will work, but it's generally dry and granular. Get a wet detergent like dish detergent, put it on your hands, and coat them as if you're putting a hand cream all over. Coat every square inch, every square centimeter of your hands with the soap or the detergent first. And what you do is you work it in, and it mixes with all of the oil or grease on your hands, and suddenly, when you get it wet, almost every bit of it will come off. So you have done a trick that prepares all the oily material on your hands to be capable of dissolving in water. So how does this work? How does a soap work or a detergent work? It's because the molecules of soaps or detergents have two different ends. One end of the molecule is polar and will dissolve in water. The other end of the molecule has the same type of bonding as an oil. So a soap or a detergent is literally a molecule that has two different ends that function in different ways. One will dissolve in oil, one will dissolve in water. And if you mix it into an oily material right away, very aggressively, and then add your water, literally all of it will dissolve away and you'll get it cleaned off right away. So that's a very useful thing to understand. So you've rendered the compounds miscible. And there are even compounds that do this for foods. And this is a very interesting thing. A lot of people love to cook, or they like to cook, but you take some vegetables, you put a little seasoning in there, and they're okay. Nothing to write home about. And then you go to a friend's house and they're cooking and they put a little this and that, and they do the same thing that you did, but somehow the flavor and the aroma is better. What did they do? This is it's a very funny trick, and it comes right to the term of miscible. The problem that you are encountering is this. For many seasonings, many spices, the compounds that render the flavor, that deliver the flavor or the aroma, are oil soluble. And so they don't dissolve very well on your tongue. You only get a little bit of the effect. What you do is you mix something with them that makes them soluble, miscible, with water, and then suddenly the flavor explodes. So what do you use? Well, if you ever take the wrapper of a candy bar and you're looking at it and it says emulsifier, and you're like, what is that? An emulsifier is a material that is like a soap or a detergent in that it allows those molecules to dissolve in water. And you'll often see the ingredient carrageenan, which is an emulsifier. There are many natural molecules that exist in other materials that act that way. One of them are starches. If you know about how to make gravy, put a little oil in the pan, you put some flour in there, you fry it until it's browning a little bit, and then you add the water or whatever you're going to use, you whip it up, and now you can add all your flavorings, your bouillon, your onions, whatever you got in there, and let it simmer. And what happens in this case is the starch molecules act as your intermediary. They emulsify the flavorings so that your tongue can taste the dissolved portions of the molecules and the flavor just explodes. This is what you do. You use an emulsifier. You can do the same thing with cornstarches. So this is a very useful trick. If you want to improve your cooking skills and make the flavors expand in what you're working on, use an emulsifier. Starches are good. Cornstarch is good. Flour is good. There are many things that will do it. It's not necessary to go out and buy literally an emulsifier. In many cases, you will see that chocolates contain emulsifiers. Now, why is this? Well, it's actually because of the very simple fact that chocolates are fatty molecules. Chocolate is from a fermented bean from the cacao plant, and it is an oily molecule. And yeah, you can smell it, you can taste it a little, but the flavor doesn't really expand until you mix it with a little cream and an emulsifying compound. And once this happens, the flavor appears to magnify. It's something that gives you the leverage of being able to sense those molecules. Remember, the sensors in your tongue, the taste buds, can really only effectively work with water-soluble materials. They're most effective for that. And that's why just a little bit of salt has a powerful taste, and a little bit of sugar has a powerful taste. But if you try to taste something oily, like butter, yeah, it's got a flavor, but it also has more of an aroma than the actual flavor. You're getting this tactile sensation of the oiliness. And so this is the thing. You need molecules that dissolve properly, and miscibility, making them miscible is the term. That's what you need to do. And by the way, what makes butter taste the way it does is a compound called butyric acid. Now, let me explain something here. If you were to go buy butyric acid at a chemistry store, there's not many of those around these days. If you were to go down and buy butyric acid and pull the lid off, and it would knock you down. It is the most horrid, awful smelling stuff. But there's a tiny, tiny hint of it in butter. And that is where the compound was discovered. And that's what gives it its characteristic smell and taste. So, and again, use an emulsifier and the flavor of the butter goes way up. That's why buttered bread tastes so good. It's interacting with the starch in the bread and becoming far more soluble so you can taste it properly. So, think about this. Miscible simply means that you can dissolve it in water. That's an amazing thing. And if you use soaps, detergents, and emulsifiers properly, they literally can change the way you perceive your life and the way you do things. Simple tricks, and I hope these two little tricks I've taught you will prove to be useful. Try them in your cooking, try them in cleaning, and you'll also find that if you have an oily stain on a fabric, in many cases, if you put liquid detergent directly on the stain, work it in, get it fully saturated, doesn't need to be dripping, but saturate the stain, you wash it off in warm water, and virtually all of it could disappear. And you've used this a lot. And then when you're done with that, if you have to, if something persists, a few drops of hydrogen peroxide will usually get rid of a lot of the rest. So a couple of tricks you can use right there based on miscibility and, of course, bleaching. Peroxide is a bleaching compound. Here's another interesting fact, real quickly. Has nothing to do with miscibility. But when you bleach something, you're not cleaning it. You're not removing the stain material. You're literally transforming the molecules so that they become colorless. They're often still in the clothing. And this is why over time, the clothing will yellow. It is the breakdown or oxidation or the rancidity of the persistent molecules that leave the yellowing behind. Peroxide, oxygen-free oxygen bleaches will often get rid of it a little more effectively. So just a thought. So anyway, miscible, now you know. When something is immiscible, oil and water, they separate. If it is miscible, they can mix. The addition of a detergent or a soap will often make that happen. So, at this point, if anybody has any questions, we are open for them. And I'm going to hawk my wares. I want you to go to schultzlaboratories.com or universesciencecenter.com and look for our publications that are on sale. The Fossil Hunter's Guide to Mars is about a 423-page download book, all about some of the findings that I made 18 years ago. And I think you'll find that a fascinating read. You'll also find The Living Galaxy, a book that I wrote about the different potential habitable worlds, what it would be like in different solar systems with different star types, what sorts of planets there are out there to be found, and what the conditions on many of those worlds might be like. Go ahead, find a copy, buy the download. Everything you do to help us, to support us, is a positive thing. We're making this Science Center grow and making this education available for everybody everywhere on Earth. I also have a science fiction novel on there as well, Oneiros. You may actually enjoy that. It's a lot of fun, and it talks about why the skies are silent. It is a science fiction, so I've taken a few liberties in there, but I think that you'll enjoy that a great deal. So all three of those books that I've written are available as downloads on the site. Meanwhile, do join us 6 p.m. Eastern Standard Time every weekday for the Randomizer. If you have any ideas, any questions, any comments, join us for this live presentation. And we're going to add a phone call-in line very soon for people who wish to participate that way. I think that that's basically the presentation for today. I hope that this was informative and helpful. And I have one last thing to present. I almost always do a scripture at the end of these things. And some people might not like it. Tough, you know. I do. And this one is, for I tell you, until heaven and earth disappear, not the smallest letter, not the least stroke of a pen, will by any means disappear from the law until everything is accomplished. And that's Matthew 5:18. I think we can see that the governments of this world, the control systems of this world, are really a mess, and they appear to be coming to a head. There are better systems. There's certainly a better system, and you can trust it's on the way. So we have to get into our worst before we see the light at the end of the tunnel, unfortunately. And I wish everybody a good life, and make this a better world, please. Thank you for watching tonight, and we hope that you'll join us later, and that you'll learn something, and it's been a lot of fun. It has for me. Thank you, everybody, for supporting and watching. Have a great evening.